Assalamu alaikum students. So our today's topic is ellipses, one of the conic sections. An ellipse is the locus of points such that the sum of the distance from any point on the ellipse to two fixed points remains constant, meaning as a conic section circle, it is the locus of points which is equidistant from the circumference to the center. So for ellipse, it is the sum of the distance from any point. So any point on the ellipse, any point on any point like this point on the ellipse, from here, the distance of any point on the ellipse to the fixed point, and those two fixed points are the focus. The sum of this distance plus this will be equal to the sum of this. So there's any point, if you choose any point on the ellipse, from that point, sum of the distance of that point to the focus will be constant. Okay, and these 2 points, each point is the focus, the plural is focus. These fixed points are the foci of the ellipse. Okay, now D1 plus D2 remain constant for all points on the ellipse. Any point, the distance from that point to this focus plus to this focus. If you add those two distance, it will be constant. This is what an ellipse is. Parts of an ellipse. Okay, like parabola, the horizontal parabola and the vertical parabola, we have an ellipse, horizontal ellipse and the vertical ellipse. But let's discuss the parts of an ellipse. This is an ellipse. The major axis, this is the major axis. The longer axis of the symmetry of symmetry of foci is the major axis, the longer axis on which the longer axis of symmetry. Why is it called symmetry? Because it is symmetrical from on both the sides, is the major axis, and it contains the longer axis always contains the foci. Okay, the longer axis contains the foci. And minor axis, the shorter axis, there are two axes. You can see this axis and this axis. This is the major one because it's the longer one. This is the minor one because it's the shorter one. So the shorter axis of symmetry. Okay. Now center, the intersection of the two axes. Okay, the point of intersection of the two axes, meaning the point of intersection of the two major and minor axes. This is the center. The point of intersection of major and minor axis is called the center. Vertices, the endpoints of the major axis are called the vertex, and the endpoint of the minor axis are called the covertex. Okay, and the plural of vertex is vertices. So the endpoints of the major axis. Okay, the longer one. And the center, it's at the center, so you can find the center. If we know the two vertex, we can use the midpoint to find the center. If we know these two vertex, we can use the midpoint formula to find the center because it's in the center. Okay, vertices, the endpoints of the major axes. Co-vertices, the endpoints of the minor axes. And the foci are always on the major axis. I'll tell you how to find out foci. There are two types of ellipses. Horizontal one, when the major axis is the horizontal line. vertical ellipse when the major axis is the vertical line. Okay, so let's name them. If it's an horizontal ellipse, this is the center always. Okay, so this is the major axis because it's the longer one, and these points are called the vertex. This point where it ends and this point, these are the focus because focus are on the major axis, and these are this is the minor axis, this is the minor axis, and this is the major axis of symmetry. So these points are called the co-vertices. So co-vertex, single is called co-vertex. Okay, the same for the vertical ellipse. The longer one is the vertical line, so this is the major axis, deciding on the line and the length. Okay, this one is the minor axis, this is the center, these are the two co-vertex, these endpoints. Okay, co-vertex, this is the vertex, vertex, this is the focus because focus is always on the vertex. Now let's say, using how far are they from each other? From the center will be always HK. Let's write it here. Center will be at HK. If HK is 0, then it's the center. The vertices of the major axis, okay, on the major axis, are A distances away. So if it's on the right of the center, then it's A distance away from the center. This is also A distance away from the center. So plus minus A. If this is on the right side, we add it. If it's on the left side, we subtract. So the vertices are plus minus A units away. The co-vertices, we use the distance. We use B. This distance is B, this distance is A, and this whole distance is A. Okay, so the co-vertices are plus minus B units away. Length of the major axis, because it's A, this is A, so the length of the major axis will be 2A. Length of the minor axis will be, if this is B, this is B, 2B. The foci are plus minus C units away from the center. This distance, the foci, is C. And how to find C? I'll tell you. Formula to find C is C squared is equal to A squared minus B squared. Always A is the major axis, the length of the vertex A units away, and this is the co-vertex B units. Okay, to find C, which is the distance from the center to the focus, we use A squared minus B squared. Now the standard form of the ellipse, because there are two kinds of ellipse, horizontal. Now for horizontal, A, it's a horizontal, so this standard form is similar to the circle, so it's going to be x minus h whole squared plus y minus k whole squared equals to 1. But if it's an horizontal, because major axis is it's an horizontal, then A would be here, would be A squared, and represents B square will be under Y, represents that it's a horizontal. If it's a vertical ellipse, A will be under Y. So first of all, we'll write x minus h whole squared plus y minus k whole squared equals to 1. That's not equals to the radius, it's equals to 1. So this is how we differentiate. Ellipse will be in such a way, but it's a vertical, so A is the distance from the center to the vertex of the major axis. So a squared will be here and b squared. In numbers, if a larger number is under x, means it's a horizontal ellipse. If a larger number is under y, then it's a vertical ellipse, because a is on the major axis. Okay, now let's learn how to graph ellipses. For graphing ellipse, write the equation in standard form and graph the center, graph the vertices using the larger denominator a, graph the co-vertices using the smaller denominator b. Use the formula c squared equals a squared minus b squared to find and graph the foci. So in this case, the larger number is